Good morning, Srini.
Hello.
Okay, let's go to focus 20. Wave motion. I don't know what happened to the internet. These are the things you need to remember. Right? Transverse wave, longitudinal wave, the equation of the wave. This relationship you must know. Only way to remember this is to try the question and keep on doing it until you force it into your head. Then intensity is two formula. Cylindrical wave, not necessary. Right? It's in your book. And what is constructive interference, what is destructive interference, what is the condition for forming standing wave, and standing wave equation, how to derive that, and then standing wave in stretch string. Right? That's the equation you need to remember. And then for electromagnetic waves, some sort of magnitude you need to know to remember. Okay, let's go. What's the answer for number one? A wave motion has an equation that where x, y are in meters, t in second, which is the wavelength and the speed of the wave. Okay. What's your answer? Didn't do your homework.
No, I did, but not everything I tried last.
How to survive like that? You won't survive. Right? Didn't do homework, you say you do homework.
Donkey.
Is it moving in the positive x direction or negative x direction?
Negative x direction.
Good. Right? So you must know the standard formula. This is for positive x direction. Then from there you can k, that's your k. Right? So put in your k. Right? You want to find lambda, take the k down. So it's 2 pi, k is 4 pi, so it's 0.5 meter. Then your omega is your omega, which is that one there, 200 pi to pi f. Right? You have to find your frequency first because you can find the speed. So take the 2 pi down, get that, put in your value. Omega is 2 pi, 200 pi divided by 2 pi, so it's 100. So speed is v times f. So answer is 50. Wavelength is 0.5, so correct, donkey. Okay, number two. Figure shows the graph of displacement y with distance x for progressive wave at certain time, at time 0.4 second. Later, the profile of the wave is shown in figure 2. The frequency of the wave. What is the frequency of the wave? Yep, what's the answer?
Donkey also.
Okay, first we have to calculate the wavelength. From this diagram is 0.2. Then you can calculate the speed. Right? Wavelength, you can calculate the speed. We can refer to one point here. You have to move a distance 0.1 knot. Right? So 0.1 0.12, you can take this part, doesn't matter. You can take this part. You take this part, then you must take the corresponding part on the waveform. Subtract that. Then you can find the speed. And from there, you can find your frequency. Okay, or you can calculate the number of wavelength. Right? Same thing. Right? So many ways to do it. Okay, good. Donkey. Okay. Number 3, 4, 5. Refer to the graph which represent the simple harmonic motion of a particle in a progressive wave with speed 5.0. What is the frequency of vibration? Yep. How to calculate frequency? What's the period?
50. Frequency is 50.
What's the period?
Period 0.2.
0.2. Are you sure?
No. Period is 20.
21.
20 millisecond.
Then how to calculate?
MS.
How to calculate the frequency?
1 over T.
Okay.
So 1
good.
over period.
Right. Period must be able to read 20 millisecond. And F is 1 over T. Convert it to second. Right? 10 to the power minus 3, take to the top is 1,000. So it's 50 hertz. Donkey, correct. How about number 4? Amplitude of vibration. Yep. What's the amplitude of vibration? Why take so long?
Amplitude or vibration. Boy.
Boy. Okay. Boy. Wavelength. How to calculate the wavelength?
V equals to F lambda. You want to find the wavelength
equals to F times lambda.
Speed over frequency.
That's why you have to keep on doing it and you force the formula into your head. Lambda is V over frequency. Put in your value and get 0.1. So it's A. Good. Right? I will break it up into probably half an hour. Then the last half an hour, we will probably start a new topic. Right? I hope you have done your worksheet. Treat that as your take-home test. I know whether you do or not after that when we mark together. What's the phase difference between 2 points separated by a distance of 3 cm with a wavelength of 5 cm? So what formula to use?
Two pi over the wavelength times the distance in terms of rad.
So what's the answer?
3.8.
Why so many answer D one?
I just said 3.8 lah.
Yeah. That's why I'm thinking why they put all the answer D, which is very bad lah. This type of answer because students just randomly choose D, then they will get it right even though they don't know. Okay, good. Right, there's the standard formula. Take the 2 pi across there, got that. Then put your X value in. X is 3, wavelength is 5. It's okay, both of them is cm, no need to convert. Then you can, right, you want it in radians and multiply it out. Okay, number 7, the graph shows the displacement of particle in a rope caused by traveling wave at a particular time. Which statement is not true of the motion of the wave in the rope? Speed of the particle at P is maximum, is it right?
No.
Okay. Acceleration of particle at Q is 0.
It's correct, sir, but they want not true.
So you are saying the answer is A lah.
Yep.
Energy of the particle at R is entirely potential energy. At R, entirely potential energy. This one you have to do a bit of simple harmonic motion. Is it right?
It's right.
Okay. Energy of the particle at S is entirely kinetic. Yep. Is it true?
It's true.
How do you know?
Because it's at 0.
That's not the reason. That's not the answer. How? So because it's 0, it must have maximum kinetic energy. That's memory work. But how
So
do
that
you
means potential energy is 0. So
how do you know?
kinetic energy is
How do you
the
know from the
highest.
graph? That is important. Not memory work. How do you know from the graph?
Because the S is at the displacement of 0. That means it's moving really fast. Like at the moment you suspend what?
Look at the slope. Right? The slope here is maximum. So it must have maximum velocity, maximum speed, maximum kinetic energy. That's how you look at it. Not memory work. That's so many things to remember, you may forget. Right? Look at the gradient. At S and Q is maximum kinetic energy, so potential energy is 0. Okay? So correct. Answer is A. Okay. This is a bit more challenging. The graph shows two sinusoidal curves. Which of the following pairs of equation represent the curve? Right? Look at R first. Yep. What's the answer? What's the equation for R? Yep. What's the equation for R? Can refer to your note if you haven't done your homework. The thing is to know the equation for R first. Then you can get for S. Yep. What's the equation for R?
This question I don't know, sir.
It's a cos graph. Huh? Yeah. Cos graph. So it's either these two answer, cos graph. Yeah. R is a cosine graph. So if you will to write the equation, then after that, you look at the same point here, this is 0, and then estimate that each of them is 1/8. Right? This is 1/8, pi over 8, pi over 8. Okay, so this is pi over 2. Right? Yeah, shifting the peak to the right. So this is pi over 2 plus pi over 8. So it's 4 plus pi. Pi over 8 is 5 pi over 8. Right? So S lags R by pi over 8. Right? Or you shift it. You shift by pi over 8. So you just put a negative there. Right? That's the standard equation. That's your shift. The shift is there. Pi over 8. Right? So answer is B. Okay or not? Anything not clear? Yep. Anything not clear? First, always remember, get one of them. What type of graph? Is it a sine or cosine graph? And then look at the peak there. What's the phase different? There's a phase different. Pi over 8. Shifted to the right, so it's negative. Can?
Can.
Number 9. Sorry. This one is the same question. It's just done differently. Right? This one is 0 is pi over 8. So I'm just choosing another way to do it. I think the previous one is better lah. This one using too many maths and then too confusing. Right? So I won't encourage you to do that. Okay. Number 9. A transverse progressive wave move along a stretched string from left. Right? This progressive wave on string move from left to right. The figure shows the appearance of the string at certain instant. Right? It's moving from left to right. Which of the following shows the direction and velocity of particles at 1, 2, and 3? Yep. Velocity of particle at 1, 2, and 3. Where is it?
Donkey. Down, up, down.
Okay. Displacement distance graph is a displacement time graph. Right? X is just your V and t, and V is constant. So V, you can think of this is the velocity. Right? V is the gradient of tangent to the curve. Right? The tangent to this curve there. This is negative. This is positive. It's positive. So look at where they are. That's all. Right? They are different. For particle 1 and 3, the velocity are positive and downwards. Right? How do we know it downwards? We let the graph move a little bit. Right? Even though we got positive, but it's moving downwards. Particle 2, the velocity is negative. Right? Gradient is negative and thus upwards. Donkey, correct. Okay, number 10, a progressive wave is represented by this equation where x and y are meters, t in second, y is the frequency, wavelength, and speed of the wave propagation. Right? You can see that these are all repeating questions. If you don't know how to do one, you will know how to do the others. Yep. How to calculate your wavelength?
Two pi over lambda equals to 4.
Okay, that's your K. K is 4.
K equals to 4.
Calculate your lambda, 2 pi over 4. How to calculate your frequency?
Frequency 2 pi f equals to 20.
Okay, omega is 2 pi f. Right, subtract your f, take the 2 pi down, and
Omega equals to 20.
put inside there.
You get the answer.
Value,
Yes.
calculate out. So how to calculate the speed?
V equals to f lambda.
Right, I'm trying to make you speak it up, then you can force into your head and memorize it. Okay, is it moving in the x or y direction? Is it moving in the positive x direction or negative x direction?
Negative x direction.
Good.
Whenever I look at that 4x plus 20x, just assume the opposite. Positive means the means is going negative.
Yeah, they can
Negative
write
means
any
going
way they
positive.
want, but you can just rewrite it. It's still positive. Donkey, good. Okay, superposition of two progressive wave of the same frequency and amplitude, but travel in opposite direction with the same speed produces. What's the answer?
Boy.
No.
This one I don't know.
Right? Standing wave amplitude will be 2a and same frequency, it doesn't change. Right? Progressive wave each has frequency f. So when they form, it doesn't change the frequency. We just suppose using principle of superposition, the frequency stays the same. Right? A. Frequency doesn't change. It doesn't become when the two in opposite direction, it doesn't become a progressive wave. It becomes a standing wave with amplitude 2A. Sound wave of frequency 400 Hz move in air with a speed of 320 meters per second. What is the phase difference between 2 points on the wave which are separated by 0.2 meter? Okay, how do I do this question? Yep, what must I do first? I can see that you have not done your homework.
Boy, lambda equals to speed over frequency.
Lambda equals to what?
Speed over frequency, which means
Okay.
320 divided 400.
You have to calculate your lambda first. Right? Then, what's our next step? Yep, what's the next step?
0.2 meter equals to 1/4 lambda.
Right? Must go this formula. Right? You want to find your phase difference. There's your phase difference. Okay, take your 2 pi across there. There's 2 pi. X is 0.2. Y is 0.8. Pi over 2 radian. The answer is B. Okay. Let's try a few more. The figure shows a pulse moving in a positive x direction. The pulse is reflected at the rigid boundary D. Which of the following graph best represent the pulse after refraction? Yep. What's the answer?
A.
Pulse is reflected 180 degrees. So it's inverted. Okay, good.
So
A.
inverted, yeah, it will go to the left side. Because even if you change it down means then it'll go leftward. So,
Yep. If the output power of a sound source emitting spherical wave is 100 watt, the intensity of the wave a distance of 5 meters from the source is, what's the answer? What equation to use? Yep, what equation should I use? Haven't done, refer to your note. Yep. What's the answer?
A.
Well, let's see. What formula to use?
I equals to watt over meter square, which means 100 divide with 4 pi bracket 5 square.
Okay, this formula you might remember. P over 4 pi r squared. R is the distance away. Right? This is your area, surface area. Remember the energy is spreading out over the surface area of the sphere. That's why we do that. It's 100 4 pi? The answer is A. Okay. In a stationary wave, okay, what's the right answer? There is no phase difference between particles in between neighboring nodes. There is no phase difference between particles between two neighboring antinodes. There is no phase difference in amplitude. There's no difference in amplitude of the particles in between two neighboring nodes. There's no phase difference in the amplitude of particles between two neighboring antinodes. Yep, what's the right answer? Yep.
This A, teacher.
Okay, you can look at this graph. Right? You focus on the dark line, then this one is moving down, this is moving up. Right? All these points are moving up, all these points are moving down. It's just like that. That's all. Right? That's how they oscillate. Or if you are focusing on the broken line, this one is moving up, this one is moving down. Right? So there is no phase difference between particles in between two neighboring nodes. There's a node. There's a node. Okay, so they are no phase different. They are in phase. Correct. There is no phase difference between particles in between two neighboring antinodes. Right? There are no phase difference between particles in between two neighboring antinodes. What are they saying? There is no phase difference between particles in between two neighboring antinodes. This is your antinode. There's your antinodes. Right? So there's a phase difference. This one is moving. Right? Phase difference is 180 degrees. This is moving up. This is moving down. So wrong. Pi radian. There's no phase difference in the amplitude. There's no difference in amplitude of particles in between two neighboring nodes. Neighboring nodes is just here. Right? The amplitude is different. Each of them has a different amplitude. The maximum is at the antinode. So false. There is no difference in the amplitude of particles in between neighboring antinodes. Right? Unless they are same distance away, there's no difference in amplitude. But if they are, there is no difference in the amplitude of particles in between neighboring antinodes. Antinodes is here. Antinodes is here. Right? So the particles all here have different amplitude. Particles here have different amplitude. Unless you take the same point from the node, then the amplitude is the same. Right? So false. Answer is A. Right? Let's try a few more. After that, we will stop for a while. Right? That's your equation. The equation represents a standing wave in a stretch string where S equals to displacement of particle in cm, r is a distance along the string from the reference point in cm, t is the time, the distance between two neighboring antinodes. Yep. How to calculate? Can? Can or not? Can or not? Right? Oh, what is amplitude? Right? That's the amplitude. It's what? It's amplitude. Okay. That's your S.
Okay.
Then for antinode, you want your that equation to be 1. So when this is 1, right, you want it to be 90, sine 90, or sine 270, pi over 2. Right? And another pi, if you want to, then can calculate. Okay. Take the 2 across it, become 1, 3. So distance between A and A is 3 minus 1. 3 minus 1. Right? This one is all in meter. That's 2 cm. Sorry, not in meter, in cm. Then K. Okay. So it's 2 cm. AA is 2 cm. Or you can find your K. Right? Same thing. Find your K. Right? That's alternative method. You can either 3 minus 2 is 2 cm, or you can use K. You can find your K first and then find your lambda. Right? This one you have to know that. From node to node is half lambda. Then 2 cm. So either method, this method, or that method, whichever is easier. This one you need to remember that antinode to antinode is half lambda. Then from this equation, calculate your, from the K, calculate your lambda. Okay, one last one. Then we take a break. This one. Standing wave is obtained by superposition of two progressive waves represented by the equation. The energy at each point along the stationary wave is proportional to, yeah. Right? You need to remember all these equations. What answer?
C.
C. Right? How to work it out? Right? You can either add these two up or use memory work. Okay, so yours is a sine. Use this equation. And that's why you get amplitude. Know how to read that this is the amplitude. That's the amplitude. Energy is proportional to, right, amplitude square. Right, so C, good. Okay, we'll stop here. Give you 5 minutes break. You want to carry on doing your work, or you want to take a short break to have a drink, go ahead. No point in trying to force you, let you have a break.
All right, okay, Chef.
Okay, have a break.